Today we're going to start our lesson on scatterplots. And in 8th grade math, y'all missed all this unit that we learned. And so I'm going to, in like 3 minutes, catch you up from 8th grade, okay? A scatterplot is a graph where you compare data. And data is just two pieces of information. So I'm going to give y'all an example. Let's say I own a snow cone shop. And I want to know, is there a relationship between the temperature outside and how many snow cones I sell? What do y'all think?
In December you sell more.
So why is that though?
Because it's hot.
So I want to know if that's true. So as a snow cone person, I take data. I take the information. And every day I record the high temperature outside and how many snow cones I sell. And let's say I document this data for a whole year. And if my graph looks something like this, then I can assume the data is related because the data, the dots, are grouped together and they're doing something. What are they doing here? They're rising. They're moving upward. And so this is called a positive. Not only is it positive, but it's moving in a straight line pattern, which is called a positive linear trend. Meaning, I could assume based on my data as a snow cone shop salesperson that if the temperature's hot outside, I'm going to sell more snow cones. And if the temperature's colder outside, I'm going to sell less. Now, is it always going to happen? No, there's going to be those random days where it's super hot outside and I don't sell many, or it's super cold and I might sell more that day. What if there was a field trip? Kids love to spend money. Even if it's 50 degrees, are they going to go buy a snow cone? Yes, so there are those random exceptions to the rule, but it shows me there is a relationship. Yes? Now look at this middle graph. What do y'all think this one is? There's no relationship at all. So let's say as a teacher, I take all my students' height and I write it down and then I take your grade in algebra. This is what my graph would look like because your height has nothing to do with your grade. Make sense? This is called no correlation or no relationship or no association. You could see any of those words. What do y'all think this last one's called? Negative linear. Now, what would be an example of this one? Let's say I own a snow ski rental shop up in the mountains. As the temperature goes up, what's going to happen to my snow ski rentals? The snow's going to start melting and my rentals are going to go down. That is a negative relationship. As X increases, Y decreases. And so these are the three types of graphs. There are also nonlinear relationships. You don't have to draw this, but they just kind of look grouped together and then they go down and then they swing back up. That is a relationship. Do y'all see how it's like curving? That's just called a nonlinear relationship, and we don't really study those in here. Okay, the next thing we're going to learn is how to make a scatter plot. To do that, it's super easy. You just graph the points. That's it. So on the x-axis, what is it labeled? Length. And on the y-axis, it's supposed to be labeled speed. And so what we're trying to do here, let's say I am a scientist and I am studying the length of a fish to their speed. So we want to know if a fish is longer, does it make them faster? So we're going to go graph this information and see if there's a relationship. Now, do y'all notice that the x-axis is counting by 5s, the y-axis is counting by 25. So is my graph going to be beautifully perfect? No, I'm just going to put it in this best spot. So when a fish is 37.8 centimeters long, so I'm going to find 35 and 40, I'm going to go kind of in the middle. It is 148 centimeters per second. So it's like almost up to 150, so just somewhere in there. All right, the next one. When a fish is 19.2, which is right here to the left of 20, it's 47 in speed, just somewhere in here. 21.3, it's going to be 88, so somewhere in there. 26.2 is 131, so somewhere like up in here. And 26.8 is 98. somewhere in here. Now, if I had more data to graph, do you think it would help me see a better picture? So the more data you have, the more accurate your like predictions or your associations are going to be. But do you kind of see a pattern here? Yeah. I'm tending to see what?
You're right.
Tell me more. You're right.
Transpose.
As the length increases, the speed tends to increase. So when it says describe the correlation, I would say as length increases, speed tends to increase. Now you don't want to say always, but it tends to. Are y'all good with this? Super easy, yes? As length increases, speed tends to increase. Okay, flip to the next page. Now we're going to graph, and this one's super important because I do think you'll see these on your assignments. But basically, I'm a scientist in this problem, and I am studying woodpecker clusters. So you'll know how scientists like make sure species aren't going to become extinct. They want to make sure that they're not overpopulating, but they're not losing off, right? So the table shows the number of active red woodpecker clusters in this national forest in Mississippi. Now, here's the problem. The table is not labeled correctly. On the X values, they have the years, yes? But look at the graph. What does it say? That means year 0 is 2005. So this is going to be X is 0. And then what am I going to count by just going up? Ones. So I'm not going to use those years. I'm going to use 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay? All right. We have some questions to answer. Based off of this, it wants us to describe the correlation. Well, what do you think I need to do? I need to graph it. So in year 0, there was 22 clusters. In year 1, there was 24. And then just go graph them all. All right, so how would y'all describe the correlation?
Positive.
But give me more. As
As the years go up, the active clusters go up.
correct. As years go up, the active clusters increase or go up, however, whatever vocabulary you want to use. Now we're going to do the algebra part with it. We are going to write an equation of the line of best fit. It is so easy. So, do y'all agree that if I was to connect the dots, it would definitely not make a straight line? But the pattern does. The trend does. Just like I told y'all on this page, it's moving in a straight line pattern. Your calculator will do this for you using what button? Stat. Now, here's the problem. If it's a perfect straight line, you only need 2 dots to go in stat. But because it's not a perfect line, and we want a line of best fit, you have to put in every single number into stat. So that's the only part that's not fun about this lesson, is every one of these has to go where? In stat. So we're going to go to stat. Edit. We're going to clear out our list. And we're going to put in 0 through 8 for our L1s. Again, you have to put in every single number, and it's very tedious. For your L2s, you're going to put in your active clusters. You are then going to let stat calculate the line of best fit the same way we've been writing equations with stat. So you're going to go to stat calc option 4 and hit enter until it gives you the answer. Now I'm going to cover my screen because mine is set to give me extra information. I don't want y'all to see it yet. That is your equation. It's usually going to be some crazy decimals. If they go past the hundredths place, I want y'all to round to the hundredths place value. Does everybody understand? What are we rounding to? Hundredths place. So what would my equation be? Y equals 3.7. X plus 19.87. So my equation of line of best fit, and we can just use this, is Y equals 3.7x plus 19.87. We're going to round to the hundredths place if needed. Was that easy? Now, why would we want an equation of line of best fit? Because you can use it to make predictions. So pretend I'm the scientist, and I say, based on this data, how many woodpecker clusters would there be today if the trend continues? Well, what year are we in today? 2025. How many years was that from 2005? So 20 years later, how many could we predict there would be today? You will use your equation of line of best fit and plug that in for X. That's it. So I would say 3.7 times 20 plus 19.87, and I would let the calculator calculate that for me. So I go to my home screen. And I could predict that if this trend was to continue, there would be about, y'all, what do y'all think I should round to if I'm talking about clusters? Whole number. So how many do we think there would be? About? 94. So about 94 clusters today. So do y'all see why these are important for scientists to use to make predictions about these endangered species or whatever? Yes, they can use it to say, if this trend continues, how many would there be in the year 2050? And then they would just plug it in and see where it would be. Yes? Now, this next part looks kind of like your assignment. We're only going to do one of these because it's super easy. It says to draw a line of best fit. You're not going to do that part on your assignment. What you are going to do on your assignment is you're going to list 3 things. You're going to write an equation of the line of best fit. So where are you going to use for that? Stat. And then I want you to identify what's called the correlation coefficient. And so I'm going to skip, don't do it yet. We're going to skip to this part. I want to teach you about this real quick. What is a correlation coefficient? A correlation coefficient is denoted by the variable r in your calculator. It is a measure of the strength of the linear equation. So, I want y'all to go back, just look with me. You don't have to turn your paper. Do y'all remember this one we just did over the fish and lure links? Was that a super strong relationship? Not really, but was it related? Yes. The closer the dots are to making a straight line, there's super strong relationship. So look at this one. Was this one really close to making a straight line? Then this would be a very strong linear relationship, where this one would be a weaker relationship. The correlation coefficient tells you if it's weak or strong. That's all it is. So if you don't have a graph, how would you know if it's weak or strong? By letting the calculator give you that number. The way you read it is when r is close to 1 or negative 1, the relationship is very strong. Like if you get a perfect 1, that means it is a straight line. If it's like 0.96, it's very close to being a straight line. If it's like near 0, then it is weak. It's basically no association at all. And then I gave you examples here. So do y'all see if it's a perfect 1, it's a perfect line. If it's close to 1, put example 0.98. It's really close to being a straight line. If it's close to -1, it's just close to being a straight line going down. And if it's close to 0, like example 0.2, then there's no relationship at all. So again, why would we care about the correlation coefficient when we don't have a graph to look at? So what if I just had a data of numbers? What if I just had this and no graph? It would tell me if it's strong or weak. So I'm going to show y'all. Y'all don't have to do it yet. I'm going to show y'all. I just put this one in stat. Yes, I have it in. If my correlation coefficient is on and I go to stat calc, it's going to give me an R. Do you see the R number? Is that very close to 1 the whole number? Then that means this line has a very strong linear relationship, which we knew because we graphed it. So why do we use this? When we don't have a graph to see if it's strong or weak. The R squared, I have no idea what that is. So don't look at it. Like, okay? Now, how do you get your R on? So to get your R on, you're going to go to your catalog and your calculator. Okay? And then from there, you're going to scroll until you see diagnostics on. So find in your calculator in blue above this 0 button, find where it says catalog. Okay, so do y'all see above 0? Right here in blue. Go to 0. In blue, do y'all see catalog? Hit second catalog, and this screen's going to pop up. You're going to scroll down to the D's because it's alphabetical. So just hold the down button until you see diagnostic on. And then you're going to hit enter and then hit enter again, and it should say done. And that just turned those R's on for you in stat. So now if you have your old list in, if you go to stat calc option 4, those R's will pop up. That's it. Super easy. Okay, so go back to these examples. We're only going to do one of these. On your assignment, you're going to have 3 jobs. You're going to write an equation of the line of best fit using stat. You're going to identify the R, and then you're going to tell if it's positive or negative or whatever. So I think it says like describe it. Okay. How am I going to write an equation from a graph? What would I need? What do I need to put this in my calculator to get an equation? I need the coordinates. So I need to make I have a graph, I need to make a table. Now, if the dots aren't perfect, we have to come up with a number that looks like what it is. Will ours always match? No, and that's okay, but it should be very, very close. So look at the first dot right here. Where is it at? I need a coordinate. -1, -4. That one was easy. The next one's kind of easy. What is the x value of this dot? 0. But the problem is it's not on -3 and it's not on -2. It's between them. -2.5. That one wasn't too bad. But look at this next one. Our answers are probably going to vary, yes? Where do you think it is on the x-axis? I'd say 0.5. Where do you think it is on the y-axis? -1.2. Somebody might put -1.3, and nobody's wrong by putting that. Now, if you put -5, then you're totally wrong. It should be something between -1 and -2, yes? So your answers might vary slightly, but they should be very, very close. All right, this dot's easy. It's at 1, 1. All right, this next dot's pretty easy. It's like 1.5. What do y'all think? 2.5? And then the last one, I would say, is definitely at 2. And then what do y'all want to put? 4.2. Now, do you have to put all the dots into stat? Yes. It's tedious, it's annoying, but you absolutely have to. So we're going to go to stat, edit. We're going to clear out our list by going up to L2. Do not hit delete, hit clear, and then hit clear on L1. And go put your numbers in. Okay, now where do I go? Stat Calc, option 4. My first job is to write the equation, so don't even bother looking at the R's. If I need to, I'm going to round to the hundredths place. So y equals 2.884. So y equals 2.84x minus, somebody?
1.9.
I'm rounding to the hundredths. 1.89. What is the R? 0.98. So what is that telling us? It's a very strong positive. Why is it positive? Because the R is positive. It's a very strong positive relationship. And if you look at the graph, are those dots very close to making a straight line? Yes. Describe positive. That's it. Do I need to do more of those, or y'all got that? Got it? Okay. Go to the back. Now, this is not going to be on your assignment today, but it is on Monday, so I just want to briefly talk about it. There is a difference between correlation, which means there is an association, and causation. Causation means it will happen. Write that down. Correlation means it probably, if y'all want to write probably. Correlation means it will probably happen. Causation means it will absolutely happen. Do y'all understand the difference? We're going to go through and doing some examples. The number of snowy days and the number of hot chocolates sold at a ski resort. Do y'all think it's related? And if so, is it absolutely going to cause it to happen? Which one do y'all think it is? It is correlation. It is probably going to cause more hot chocolates to be sold. Yes? All right, number 2. The number of minutes a furnace runs and the temperature of the house increasing. Do y'all know what a furnace is? It's an old school, 1950s probably, before we ever existed, heater in a house. So if I turn my heater on, is it related to the temperature going up, or is it absolutely going to raise the temperature? It is absolutely going to raise the temperature. That is a causation. All right, the number of miles driven and the amount of gas. Causation. The more I drive, I'm going to use up my gas, period. The age of a child and the length of their hair. This one, I don't really like the question. Because, I would say correlation. I don't like it, though, because a lot of boys cut their hair, and so, it doesn't make any sense. So I would just say correlation. All right, the number of cars on the highway during the holiday weekend and the number of traffic accidents. It is most likely going to cause more crashes, yes? But will it absolutely cause them? No. The number of minutes a person spends exercising and their body weight. Correlation. It's definitely related. but it's not absolutely going to cause them to lose or gain because there's other factors involved. Yes? Okay, I'm going to get you your assignment and give you directions. All right, on 1 through 3, all you're going to do is write if it's positive, negative, or none. That's all you're doing on 1, 2, 3. On number 4 and 5, we're going to change the directions a little bit, okay? You are going to make the scatter plot. You are not going to draw a line of best fit, so mark that out. You are going to write an equation using stat, and then we're going to add this part. You are going to identify the correlation coefficient. That's your R. So I am going to grade 3 answers on this one. I'm going to grade the graph where you plotted the points. I'm going to grade the equation, which you're going to get from stat, yes? And I'm going to grade the R, which you're going to get from stat. And you're going to round to the hundredths place if needed. So that's for 4 through 7. Okay, any questions on that part? Okay, go to the back. We're going to have 4 answers on number 8 and number 9. We are going to make a scatter plot, so you're going to graph it. You're going to add this part, describe the correlation. So that's where you're going to put positive or negative. So add that in. You're going to put positive or negative. It says, if possible, fit a line to the data. You're not going to do that part. But you are going to write an equation, and then you are going to identify the R, the correlation coefficient. So you're going to do an equation, you're going to do an R, and you're going to put if it's positive or negative. How many answers? 4. The graph, the equation, the R, positive or negative. And then on the word problems, please don't skip them. They're the easiest thing ever. They give you a table. What does part A say? Make a scatter plot. So you're just going to graph it. Part B, describe it as gas goes up, temperature, whatever, goes up or goes down. For C, you're going to answer the question based on the graph. It's super, super easy. So make sure you get that done, okay? All right, you may get started.